Hello folks, so today I'm going to actually be looking at writing end-to-end tests for TCE, Council Community Edition, and I am going to share my screen. And so this is the repo that I'm going to be using and eventually move the code to TC repo, but for now just writing it here. So I have a very simple setup over here. So I put a readme saying that this contains this, and then oops, and then put a go.mod, and I'm using Go 117. So I have Go version 117.8. I could use 1.18, but I'm just going ahead with 1.17. And I wrote one simple test thing over here saying main test, or let's just call it as say Azure test for Azure. This is for Azure, so let's just say Azure test, and then let's see if I can actually, oops, let's see if I can actually run this Go test, and it says Azure Management and Workload Cluster, so that's good. So now I can actually write down what I want to do here. So first things first, I would want to ensure that TCE is installed. TCE is installed, and then or install it. So basically, check TCE installation or install it if not present. Yeah, basically that. And then, or maybe more simpler, just maybe not even just do TCE install. Maybe I can do that separately. Prior to the test run. Yeah, and so this is Azure Management and Workload Cluster. So ensure so TC or TF is installed. We just need one of these. Ensure management and workload cluster plugins are present, and ensure package plugin is present in case package test is going to be run are going to be executed. And what else? I think we can look at actually the one second. We can look at the code of the existing Azure end-to-end test to see what we need to do. I'm just gonna grab that out. So Azure and so okay. So we need to Azure slash, and then we have this. So on the top we see that the script is TCE management and workload cluster in Azure. It builds TCE principal management and workload cluster in Azure. Installs the default packages and cleans them. Supports only Linux, Debian, and macOS. All environment variables need to export it before running the script. And so we are asking for some secrets like the client ID secret, the subscription ID and tenant ID in Azure subscription, Azure tenant, and then the SSH public key that will be injected into all the nodes of the cluster, like the control plane and worker nodes, that can be used to actually SSH into those nodes using the corresponding SSH private key. And we are having a static location of Azure set to this. We could actually make this as parameterized. And we actually have error set. So whenever this error it stops, and then we also have verbose. I think with Golang, what we can do is we can control this level of verbosity and like the log level granularly. For example, ensure that we don't print any secrets to the log, and also have debug levels. But I mean, yeah, in any debug level, let's not print any secrets. And having debug levels or log levels, can say debug info, error, and things like that, and then show the logs accordingly, that much level of logs. And we are declaring the required environment variables and then checking those required environment variables, and then immediately error out if there are no such environment variables, or if they are empty or something like that. So one thing that we can do is, for example, in this case, we check the environment variables, and like with this set, I think it will show up these environment variables, the values. So in Golang, when we write, it will be ensured that we don't show these values in the logs. We just check them, and then when we give out an error, maybe we can say something like, "Hey, this is how you can actually get the Azure tenant ID. This is how you can get the Azure subscription ID. This is how you can get the Azure client ID and secret, given you created the Azure client." Or how to create it. Refer to the Tanzu communication, Tanzu community edition docs, and like send them there along with the error. Like put this doc link, and Azure SS public key. How do you create it? Some thing to it, like to say that, hey, you have to create an SS public key that is actually RSA and not anything else, because Azure doesn't support anything else actually, at least as of now. And yeah, we can give some basic docs when you give that error, and then there are some utils over here. So we can check out what this is. So this is the utils, and then there's Azure utils. So utils, we have to print error, delete client cluster. I think in Docker PS, what we can do in Golang is we can use a Docker Golang client and delete them, and also ensure that we are deleting only the corresponding bootstrap clusters and not all of them. And we can also easily do the kubectl thing using, say, kubectl's Golang library, or say whatever Golang library makes sense. I think kubectl's Golang library makes sense in this case. And then what else? So for running Tanzu in Golang, what we can do is we can either just run the command Tanzu diagnostics and things like that, or we can use the Tanzu client, the Tanzu framework. The only tricky thing with that is that the Tanzu client will keep changing over versions, and we have to keep upgrading the version. And which means that whenever we run an end-to-end test, we are actually tied to a particular version of Tanzu, which is invoking that particular plugin, say unmanaged cluster diagnostics or whatever it is. And if we assume that Tanzu is already installed, we can simply just run the command, and like, it will take care of that. Assuming that we know which command line arguments and which what is the API of the CLI. Sometimes some flags are introduced new in older versions, they don't work, so the end-to-end test will work only for some versions. So there is a version to the end-to-end test itself in that case. So and then we can say this end-to-end test version works with only these versions of Tanzu and something like that. Or it has, or our latest version of the end-to-end test should have coverage for all the versions of Tanzu. Do we need all versions coverage? I don't know. But yeah, that's that. And it will have information like which flag is present in which version, and accordingly use those flags and that commands. And then yeah, collecting diagnostics is one thing. And then what else? So that is in the utils of that. And then Azure utils, there's like things like running the Azure CLI. For this, we can use the Azure Golang SDK, Azure Golang library, and then logging in. And then I'm not sure. So this logging is done because we want to do actually this accepting of VM image. So we have to log in and then accept the VM image. So one thing that we can do is we can maybe log in and then check if this image is already accepted, and then say this image license is already accepted, instead of like always just doing it. I don't know how much time it takes, each of them takes. We can always maybe do it, or just check it and then say it wasn't accepted, so I'm going to accept it now, and things like that, because you need to accept it so that the user is clear that, okay, oh, it wasn't accepted before, so it's more clear than us accepting it just blindly always, right? And install dependencies. So this installs Docker. I think maybe we can assume that Docker is installed for now. So it checks for Docker, and then it verifies if Docker is all good. And however, Tanzu will not run without Docker. So kind of like a Tanzu requirement. And also, yeah, our Bootstrap cluster, like if we want to delete Docker containers, we have to use Docker client. And in this case, we want the server or Docker daemon also for Tanzu to work. So yeah, and then checking for kubectl. I think we can get rid of. I mean, oh, Tanzu will require kubectl, I think, or else it will fail if we give some errors. So it will do some apply, keeps it will apply things. So, and then env substitute and AWS nuke, we can get rid of it and still use maybe something else, or use AWS nuke and env substitute still. Not env substitute, but still use AWS nuke. Or I don't know if AWS nuke is like written in Python or what it's written. If it's written in Golang, we can just probably use the Golang library. Also, if it's written in Golang, we can just use the Golang library and try to get it done. And download or build TCE for this. What we can do is, instead of using, we can get the URL, of course. And instead of using curl, we can just use Golang and download this tarball to the local file system and check if this tarball is available. And if it's not available, then go ahead and like do make release. Just run make release and finally just run install.sh. Maybe even do uninstall.sh first and then do install.sh. And then finally just check some version or some of, just run Tanzu and check if the CLI plugins are available. And then yeah, the cluster names of it, like some sort of like random names there, and then a short name test, and then MC management cluster, and then for workload cluster WLD or WKLD, something like that. Or we can simply say MC, or we can say Azure MC. That's more clear, so that when we see in the context, we can say that hey, it's an Azure thing. And we can say test Azure or test AZ or something like that. AZ is availability zone though in cloud terms. That can be tricky. Anyways. So management cluster name, workload cluster name, we have set them, and then so we log them out, and then we actually hardcode the data about the image license acceptance thing. So image class publishes this VM, this doesn't change anything, won't change for some time. TKG cluster API, and then this one will keep changing depending on the version of Kubernetes that Tanzu is supporting in the TKR and TKG bomb. And these are all functions that we've defined. So the first thing that we do is we accept the image license, VM image, virtual machine image terms, and then we create a management cluster. And if it fails, we collect the diagnostics, delete the kind cluster, and then clean up the management cluster. As in use Azure resource group delete, and delete the kind cluster because the bootstrap kind cluster would be continuously creating the management cluster while we are also trying to delete it using Azure resource group delete. So we have to first of all get rid of this thing that's always creating and reconciling and creating the management cluster. So the bootstrap cluster has to be deleted, and then we have to ensure that it's all deleted and like all the components, basically the cluster API provider for Azure, those components and cluster API components are all down, and the whole cluster, it's the whole bootstrap cluster is like killed, and then we can go ahead and like delete the management cluster using Azure resource group delete, and it should be fully clean. And before doing all this, get the diagnostics before cleaning up everything. So you might get diagnostics. You will get diagnostics from the bootstrap cluster if it's running, and you will get diagnostics data from the management cluster if it's running, and the Kubernetes API server is like accessible, and you get the logs and things like that. And the creation of management cluster, you actually do it like this. We actually currently set the environment variables for Azure. So we do it like this. So what we can do is, actually, instead of doing export, we could have also done this. Like before this command, we could have just put these one by one, so that this environment variable is only accessible by this, what do you say, program. In Golang, I think we can do that very easily. This will become very verbose when we do it here. But yeah, I just did export and did it very simply. And we can use this, reuse this many places, but in Golang we can do it a bit differently and maybe better way, so that we don't export it and leak it. In this case, I export it, but later I unset it. So if you see here, unset Azure environment variables, I unset it so that it's not exported and it's not there. And the config file is still here. So Azure and then cluster config file. So this says provider is Azure, developer plan, Australia Central, standard D4 SV3, and the kind of machine that we want for control plane and worker nodes. And then what kind of operating system we want for these control plane and worker nodes. So we want Ubuntu 20.04, AMD 64, and then we want, these are actually, I think, virtual networks, and then the classless interdomain routing, CIDR range for the control plane, and then this, and then the worker node. So you can see these two difference, the one, and then this one is a bigger one. And then this is kind of like the superskeleton subsets. And then finally we have the cluster and service. So I think this is for the service IP, this is for the pods, service cluster IP, and then this is for the pods. And then this is for the customer enhancement, something participation. So you don't want to participate, and then enable MHC. And then I think this is some health check, machine health check, something. And then identity management, we don't have it as of now. And we create this using this file, and like we say the name, and then that's it. It should be created soon. And then finally, we do the checkups. If it fails, yeah, we of course go around fixing it. What we do is, oops. What we do is we actually do this. So we do the diagnostics collect in an analytical cluster, and delete kind clusters over here. Oops, over here. So you delete all the bootstrap kind clusters of TKG. That's not fair. We have to just delete some of them. Or like exactly one of them, the one that's responsible for creating the management cluster, the one bootstrap cluster. We can find that out by checking the Tanzu config files, and one YAML file has that correlation between which bootstrap cluster is creating which management cluster. So yeah. And then clean up the management cluster. So this is defined here. So you use the Azure CLI and clean it up. So you clean up the Kubernetes config also, because sometimes it is set and you want to remove it. And if it's already removed, all good. You set the environment variables, Azure environment variables, because you want to remove things. So yeah, Azure cluster cleanup. This happens over here. And you actually do a resource group delete. The group delete means resource group, and the whole resource group is deleted. And then that's all. So this is here. And so that's the cleanup of management cluster. And we check the management classification, which is very simple. You check if the you first of all get the credentials. So you do this, and you check. I mean, you check if it's running, and then you get the credentials, the key config file, and like admin config, and then you check if everything is good. You check TCE cluster creation. You check if check the things like you first of all go to that context. You can also temporarily use that context alone somehow in Golang instead of like globally changing the context. And then when we wait, say wait for all the pods, check the cluster information. Maybe do this is the first thing, and then wait for all the pods to come up, and then get the nodes, get all the pods, and show them up. And maybe even capture those details in some sort of like report like thing. And then finally, we can go ahead and create the workload cluster, and then check workload cluster, add package repository, list packages, test the gatekeeper package, and then delete the workload cluster, and then wait for the workload cluster to be deleted, and then clean up the workload cluster kube config, and then delete the management cluster. So each of these is similar to whatever we saw. Like deleting the workload cluster is a bit different from the deleting of management cluster. So workload cluster is this Tanzu cluster delete, and if it fails, we do the when workload cluster creation fails, we actually don't delete the workload cluster first. Instead, we delete the management cluster first, because that could be running and that could keep creating the workload cluster. If we keep trying to delete the workload cluster, this will be the management cluster will keep trying to create the workload cluster. We would keep trying to delete the workload cluster because it failed to create, so we want to clean up. So we first delete the management cluster, then delete the workload cluster. So you can see we say clean up management and workload cluster whenever such things happen, because there is some issue in like, actually we don't have to clean up management and workload cluster always. Like in case of create workload cluster, yeah. In case of check workload cluster creation, we have to think about it. If it's not running, yeah. In case of add package repo, if package repo addition fails, we can still delete the workload cluster first and then delete the management cluster. And then same for list packages, test gatekeeper package and all that. This is unnecessary, but we've just done it. I think you can just still delete the workload cluster and then clean up the management workload cluster. If the deletion of the workload cluster fails, then yeah, you have to clean up. So yeah, and but yeah, the cleanup is pretty fast. You can doing delete one by one, and then wait for the workload cluster deletion. This all this kind of wait we can actually easily do it in Golang, and if it's JSON, you can easily parse it and whatnot instead of using the JQ. And yeah, so delete workload cluster, delete management cluster. We just do transfer management cluster delete, and that's it. So that's all we need to do for Azure, and we'll be doing that here one by one. I'll write them down, and then I'll start doing them one by one and Golang. I will pause this and continue this in another video. Bye bye.